Hi everyone, welcome to our course. This is an overview of computer vision. My name is Bradford Tuckfield and I'm a data science consultant and I will be your instructor for this part of the course. Our agenda is quite simple today. We will start with an introduction to the idea of computer vision and we will go on to discuss some use cases and some places where computer vision is applied in the real world. Let's start with the introduction. This slide has some information about computer vision. Let's start by looking at the image here, the photograph here in the bottom left of the slide. This is the type of thing you might see if you were driving a car or if you were on a street. And you can see that if you're driving a car, there are many types of things you might see. You might see other cars, you might see a bus or two, you might see a street, markings on the street, signs that tell you how to behave on the street, and you might see other things as well. And every time you drive a car, you're going to see things like this, but not only do you see them, you have to understand them, interpret them, react to them, and behave properly in the context where you are. So computer vision is a broad field that includes a lot of different things. You can think of it as a branch of artificial intelligence, and it's going to enable a machine not only to see things, not only to take images and acquire images like a camera might, but also interpret and understand those images and even react to them. So we've had cameras for many decades, high quality cameras that can record images and take photographs like the photograph you see here. But it's only in recent years that we've tried to add to these cameras computer vision abilities. And those computer vision abilities, we hope, will enable cars to drive themselves without any human input. And so it will require all those things I mentioned. Not only do the cameras need to record the images, but the cameras need to understand what's in the image, detect objects in the image, even read text, and then react and behave appropriately based on the image and everything that's seen inside the image. So this is a complex process, and it involves all these steps that are described here: image acquisition, image screening, image analysis, and identifying and extracting information from images. So the idea of autonomous vehicles using cameras and artificial intelligence to capture images, understand what's in them, and drive a car, that's just one possible application of computer vision. We're going to talk about that and a lot more soon. Let's talk about some use cases for computer vision, or in other words, some places and times when computer vision is applied in real businesses and in the real world. We can start by talking about autonomous vehicles, or in other words, self-driving cars. We mentioned these a few moments ago, but these are something that a lot of companies are focusing on a lot, and something that could really change our lives and change the world if we're able to do it successfully. So if you think about what we need to do to have a self-driving car, there are many difficult engineering challenges we need to overcome. One of them is simply the cameras. We need to have really good cameras for our cars that can see everything. We need to see what's in front of the car, what's behind the car, what's on the side of the car. So we need to have many good cameras. They need to work all the time. They can't ever turn off. They can't ever get muddy so that things are not visible. We need to have good cameras recording good images. Well, that's just the first step. After we record images, we need good computer vision, or in other words, artificial intelligence, to interpret what's in those images. So when you're driving a car, the street is usually marked with lane lines on either side of you that tell you where your car should be. And, well, sometimes it's very easy to see lane lines and understand what they mean. But in different parts of the country or different parts of the world, maybe lane lines are drawn in a different way. Or maybe lane lines in one place are very clearly painted on the street, but in one place they're faded and they're not as visible. Or maybe there's a street where there's some construction. So there's some old lane lines and some new lane lines, and maybe the car can see both of them. Or maybe it's raining, or maybe it's foggy outside, so that decreases the visibility as well. An autonomous vehicle that works well needs to not only record images in all these situations, but it needs to make difficult decisions and inferences about where the right lane lines are and where the car should be based on what it sees in those lane lines. And this is a very difficult task. It's easy to do it in some simple scenarios, but it's hard to be able to do it in all kinds of scenarios, in every possible eventuality that could ever happen. So we use some very advanced technologies for these things. Not only, good cameras, good computer chips, good graphics cards, but also advanced machine learning technology called neural networks. And these neural networks are what the car uses, or what the artificial intelligence uses to take images that it gets from the street and interpret the images, decide where the lane line is. And then, of course, after that, once you know where the lane line is, then the computer needs to provide instructions to the car to say, steer this way, steer that way, and obey all the traffic laws. So there are a lot of really difficult challenges here, but there are many big companies with a lot of funding and with many good engineers who are working on it. Other applications of computer vision are in retail. So retail stores have a lot of challenges that right now are being accomplished by humans. So one of them is inventory management. So maybe a retail store has many thousands of items on the shelves, and regularly what they need to do is they need to keep track of how much is on each of their shelves and whether they need to order more things if some parts of the shelves are getting close to being empty. And so what typically happens is there's a human who goes and counts all the things that are on all the shelves and makes sure that the store has enough of everything. And if there's something that's almost empty, that human will order more of it. Well, you can imagine using computer vision for inventory management. Instead of a person going to check all the shelves, you have a camera, or maybe a lot of cameras. Maybe there are cameras pointed at all the shelves in the store. Maybe there's even a drone that flies around the store with a camera and looks at all the shelves. Well, a camera is not enough. Again, you need to use some artificial intelligence or some computer vision to interpret what the cameras see on the shelves. Can a camera detect the difference between a full shelf and an empty shelf or a nearly empty shelf? Can a camera make comparisons between what the shelf had yesterday and what it had today? Can the camera or the technology associated with the camera place orders if something is out or almost out? And you could imagine, if you use the right technology, if you do the right machine learning and the right artificial intelligence, you could imagine that you could have an automated inventory management system where you did not need to pay a person to do it. You could just have the cameras and the software do it. There are other applications of computer vision in retail. Theft prevention. Can a camera not only record images of someone stealing something, but can a camera make an inference that, this is not just a person walking around, this is a person who just took something off a shelf and is walking out of the store? Can it detect that in real time, and then can it take appropriate action, maybe calling the police or somehow preventing the theft from occurring? That's another challenge, and it would be great if we could do that as well. And you could imagine other applications, things like self-checkout or cashierless stores. In those cases, a camera would record you if you took something from the store. If they had your credit card information, maybe they could recognize your face and know that you were the person taking something from the store. And then as you walked out, you did not have to check out or buy it. It would automatically charge your credit card. So if the computer vision was mature enough, it would be able to do that all automatically without requiring any human inputs. Amazon has been working on some of these things, and they have some locations called Amazon Go, where they rely on computer vision to have a cashierless experience. And it's something they've been working on and that they're constantly trying to perfect. Well, there are many other applications of computer vision. In banking, financial services, and insurance, we can think of many as well. So, one thing you might think about is OCR. OCR is short for optical character recognition. So a lot of banks or financial companies, they receive huge amounts of documents. For example, checks. People write a check, and the check is used to pay for things. And the check needs to be processed. Every time you write a check, the bank needs to process the check and make sure the money moves in the right way. So, traditionally, humans would read checks and make sure that money transfers happened. But if we can do really good optical character recognition, or OCR, you could have a camera record an image of a check and then automatically determine where the money needs to move and automatically move the money. And so you wouldn't need a human input anymore. You could just have a camera and some technology to apply artificial intelligence and computer vision to move the money successfully. So, there are also applications in something like insurance, like car insurance. So, if you have an accident in your car and there's some damage in your car, if you take pictures of that damage, then a computer vision system or computer vision algorithm potentially could evaluate how bad that damage is and pay you for the damage, or go through whatever insurance process needed to happen to help fix the damage. And you could imagine lots of other applications of computer vision. Really, anytime a human needs to use their eyes to see something and interpret it, that's a case where computer vision could potentially be helpful. Healthcare is a huge part of the global economy today, and computer vision could be very helpful for healthcare. One way that computer vision can be helpful with healthcare is diagnosis. So there are a lot of medical images that are used for diagnosing things. For example, some diseases that happen in your lungs, something like pneumonia or even tuberculosis, these are detected with X-rays. So doctors take X-ray images and then they use their eyes to look at these X-ray images and interpret them and say, this X-ray image looks like someone with pneumonia, this looks like someone with tuberculosis, or many other diseases that might be detected from an X-ray. So again, instead of having humans and their eyes and their brains looking at these images, what if we had a computer vision system where a camera recorded this X-ray image, and then the computer vision software used some neural networks or used some advanced algorithms to make inferences and determine what an X-ray with pneumonia looks like, what an X-ray with another disease looks like, and classify every X-ray to say this is a healthy X-ray, this is X-ray with pneumonia, and so on. And it's not just chest X-rays, but MRI images or images we take of people's brains, even dermatology images of people's skin. And there are many companies and people who are working on these kinds of applications. This is an engineering challenge, but it's also a legal and regulatory challenge, because in most countries there are regulations about who can provide medical opinions and diagnoses. And in most countries, it's not always legal to use computers to do all of the diagnoses. Usually it requires a medical professional to do the diagnosis in a lot of countries. So there are many challenges here, but a lot of promise and a lot of potential as well. Well, there are many more applications we might think of computer vision. Things that you might want to do with your smartphone camera. And that could be something as simple as a QR code scanner, but also apps like Instagram have image filters to help edit and change the look of an image. That's something people are interested in. Facial detection and facial recognition. Potentially, you could point your smartphone at a person and it could recognize that that person is your friend or recognize that that person is a stranger. There are applications we've seen where if you point your smartphone at an image of text in a foreign language, some apps can not only read that text, but translate it into your own language. And so that's not only OCR, which is character recognition, but also machine translation. Augmented reality and virtual reality, these are some other applications. I've seen one startup that's using augmented reality to help manufacturing and help industrial processes. And what they do is you can point your smartphone at a machine that you have to work on or that you have to fix. And this augmented reality system will it will draw images on your phone where it will point to things that you need to fix or point to things that you need to do. That's an example of augmented reality. And it's a very difficult application because it requires not only computer vision to see an image, but a lot of interpretation and a lot of domain knowledge to know, what do I do with that image? How do I fix this machine? And so on. But we're seeing a lot of startups and a lot of technology related to these things being developed. So this has been an overview of computer vision, including an introduction to the idea of computer vision and also some use cases related to computer vision. Thank you for being part of this session. and I wish you all the best in your journey of learning about computer vision.